3.2 Exploring relationships between sets. This is going to be a very common sight in this unit for you, especially for the first half of it, our Venn diagram here with a scenario that's attached to it. So, in an Alberta school, they're hurtin' Albertans, there are 65 grade 12 students. Of these students, 23 play volleyball and 26 play basketball. There are 31 students who do not play either sport. The following Venn diagram represents the sets of students. Now, you have this set right here. This is our universal set. This is the set of all grade 12 students. And it says right here that 31 students don't play either. Where would that go? Where would the 23 go? Where would the 26 go? So how can you use this Venn diagram to determine the number of students who play basketball only, volleyball only, and both basketball and volleyball? The only thing that we know for certain is that there are 31 students who play neither, and everything in this whole circle is basketball, 26. So in this whole thing, 26. And this one right here is 23. But there will be some overlap because there are people who just play basketball and there are people who just play volleyball. But we need to figure out a few things first. So in order to do that, let's flip over our page here and talk about the difference between intersection and union. We're going to get to the principle of inclusion and exclusion later, but intersection is the elements that belong to both sets. The way that we say it is we would write down A intersect B. So if I were to draw a Venn diagram, and I would take out my highlighters. Good glory, I love these highlighters here. This right here that I colored in, that's the intersection. Well, then what's the union? The elements. Oh, sorry, I should write down this is A and this is B here. That's helpful. The elements that belong to either set. Okay, so in our Venn diagram, we have our intersecting sets, A and B. And the way that we would write the union of both would be A union B, and that would be this shape right here. Whoop, would be the whole thing. So A union B is this whole yellow area. So first things first, let's figure out how many actually live in this intersection between V and B. So the number of elements in V union B equals the number of elements in S, which is all the students in grade 12, minus the number of elements in the complement, the complement of V union B. So just so that we are all on the same page here, we're looking for the number in V union B, which is this one. So the number of kids who play both, or sorry, who play either basketball or volleyball. So you have to take the number of, I'm actually going to use a different color here. The total number of students here. So everybody. kind of, we know that this one's V and this one's B, so I think that's okay. So take all of the numbers, all of the students, and we subtract the people who don't play anything. So the complement of volleyball players and basketball players is the students who don't play either sport. So let's fill in these numbers and then figure out. So the number in V union B is the total number of grade 12 students, which is 65, minus the number of students who don't play either basketball or volleyball, minus 31. So the number of volleyball or basketball players is going to be 34. So we know that the number of students that play volleyball or basketball is 34. So that's what holds, that's the number of students that is in this shape right here. How can we use that information to figure out just the volleyball players, just the basketball players, and the students who play both? Well, we know that 23, so that's the number of volleyball players. So the number of, the number of elements in V plus the number of elements in basketball players, which is 26, minus the intersection. So that is the number of volleyballs intersect basketball, equals the number of students in volleyball who play either volleyball or basketball. But we know what this number is here. So let's substitute that in. So 23 plus 26 minus the intersection equals 34. So we can figure out, using our sweet algebra skills, how many are in the intersection there. So 23 plus 26 is going to be 49 minus the number of volleyball and basketball players equals 34. We're going to subtract 34 from both sides and subtract the number of the intersection. So on this side we have the number of the intersection, which makes it positive, equals 49 minus 34. So that means that the number, I'm switching sides again, volleyball intersect basketball, is 15. So if I were to erase all the things that make this illegible, I would say, I just erased the pink one. I would say that all the students in volleyball and basketball is 26. Is 34, but let's be a little bit more specific here. We now know that the intersection is 15. So if there are 26 players playing basketball, let's subtract that 15. So then we know the number of students who just play basketball, and that number would be 11. Same with this side, volleyball. You say 23 students play volleyball, but we say 23 in this whole circle, but 15 students play both, so we can't double count those students. So 23 minus 15 is going to be 8. So if we were to add 15 plus 11 plus 8, that should be our union number. That should be 34. Let's do the math here. 15 plus 8 is 23. 23 plus 11 is 34. Bingo! We got it. So this right here is just our process. This right here is the true number. So let's so what we did here, let's just give an equation here that we can follow every single time. So the principle of inclusion and exclusion states that for any sets A and B, we would say the number of elements in A union B. Let's just draw this out so we can see. So this whole structure, this circle and this circle, that equals the number of elements in A, so all the elements in A, plus all of the elements in B, minus the intersection, because that is our overlap, because we're saying all the elements here. Okay, so we count this and this once, and then all the elements here, this portion and this portion, but we need to subtract just one of the intersections because we've double counted it. A intersect B. Now for those of you who are thinking, well, what happens if they're disjoint sets? A is this one and B is this one. Well, it still works because the number of elements in A and B together are the number of elements in A plus the number of elements in B subtracting the overlap. Well, there's no overlap, so you would just subtract 0. So it even works when the two sets are disjoint. So what I want you to do is focus on the section 3.2 and answer the exercise questions following the teaching notes in the book.